All right, we're going to go ahead and talk about, yes, we're going to go right into the class, no welcome back or anything. Default routes. I mentioned it, right, in the previous lesson, but I want to give we're going to configure a default route in the packet tracer, and then, yes, in the live router. All right, but I'm going to tell you what a default route is all about. I really don't want you, when you go take your exam, I want you to have all this ammunition in your brain so you can regurgitate it onto those laminates they give you so you can take your exam. Okay, we said that static routes, was where you advertise the networks that you don't know about, right? And it's better on the router and so forth. Default routes are used on end routers, stub routers, okay? One way into the network and one way out, right? They only can go one way in, and there is no two ways. Like here, you can go this way, you can go that way. Here, you can only go whoop or whoop. So stub routers, end routers, there's where you configure default routes because you only give it one direction. What is the purpose of a default route? The purpose of a default route is so the router, when it receives a destination network that it doesn't have an entry for in the routing table, it does not drop it. Because the thing that the router looks at, the routing process that we talked about, once the packet makes it inside the router, the router will then look at its routing table to make a match to see where it needs to switch that particular destination address or that packet to whatever interface, outgoing interface, to send it where it needs to go. But if in the routing table there's not an entry for that particular destination network, normal circumstances, the router will drop it. So the default route is also known as the gateway of last resort. And what it does is it will match the IP address. It will match the subnet mask, and then you send it out either the exit interface or the next router's hop address. And I'm going to show it to you first in Notepad. I'm going to take our time with this. We're not in a hurry. All right. Now, a default route is a special kind of static route. And I believe you can see this. Let me, okay, we'll bring this up a little bit bigger, make it a little bigger. Put it right there. So you start it like you would a static route, IP route. And then you go match destination network, match destination mask, and then you can use, this is what's called using the exit interface. What is the exit interface of the first router? It's the S00. So I'm telling it, hey, match whatever, it's not in the routing table, but just match whatever network and send it out. And send it out to the next router. Because they say just switch it to that interface and boop, send it to the next router. Or you can do it IP route 0000 0000, oops. Or you can do 10.1.1.6. That will be using the next router's hop address, which would be that right there. What is the difference? Now, this is the same principle for using a default route or a static route. A normal static route versus this special type of static route. Remember, this is what you call a default route, which equals your gateway of last resort. Okay? The difference is this. If you use the exit interface, the entry on the routing table for normal static routes, not for the gateway of last resort, but for normal static routes, it will show as it's directly connected. So the router only has to do one lookup. One lookup. Where is it you want to go? Switch it to the interface. Done. If you use the next router's hop address, then when you look at the routing table, you do show IP route, you're going to have an administrative distance of 1 versus that it shows that it's directly connected. So now the router does 2 lookups. Now it goes down, says, okay, where you want to go and where do I need to send you? So, because it's got to look for that destination, the next router stop address. So for point-to-point networks, Cisco recommends exit interfaces for static routes. That way the router does less lookups on the routing table. But let's configure this. We're gonna do everything on the packet tracer, and then we'll go ahead and do it on the live router. Okay? Let's go ahead and go to this router right here. That's the very first router, and we're gonna go over here so you guys can see it. All right, let's open it up a little bit. Let's go to the CLI. Username, everything in caps, LDIAS, Cisco. All right, we got to go in global configuration. And I want to show you something before I start so you can see. I'm going to look at the routing table right now. I'm going to do, which you can't do on your certification. You have to be in privilege mode. So let's go ahead and go. Let's exit out. Okay. Show IP route. All right, and you can see it says that your gateway of last resort is not set and that you're directly connected to two networks, the 10.1.1.4 and the 192.168.1.0. All right, so that's what our routing table looks like now. Okay, so now let's go to global configuration and let's do our default route. IP route, destination network, destination mask, exit interface. I'm going to copy, I'll exit, I'll do it the right way. Not the right way, the test way. Copy, run, start. Not saying it's wrong, but just lengthy. So now when we do a show IP route, now the gateway of last resort is set to all zeros. And we have a default static route entry that is directly connected to the S000. Okay? So it's a special type of static route. Because if you look up here, let me see, because here it says, see, if you have the asterisk means candidate default. The S, I guess, is a little bit higher. I think I went a little bit too far now. Let me see. And there you see it has an S. It's a static. So you have a static default route. That's what that S with the asterisk is telling you. So nothing gets dropped. So let's go, and again, you can only do this on the end router. So let's go to the last router. And let's do that. Let's do the same exact thing. But this time the exit interface will be the S001 because we're going that way. We're here, we're coming this way. You see? All right. So let's move that more that way. Let's open that up. All right. And I didn't put no one. CISTO. Okay. Config T, IP route 0.0.0.0.0.0. Destination network, match exactly. Destination mask, match exactly. Whatever number it is, just match it. Send it out the S0/0/1. Enter. I guess I'm going to cheat. Do show IP route. So we're looking at the same thing. Cool. So now I'm going to, right from right here. Let's get the PC. Let's get PC2. Let's go to the command prompt and let's move it over here. So let's see. I do have my IP address, IP config. Right? Of course, you can't see it. I don't have no IP addresses on there. Oh, that's right. I added this to the network. I guess I forgot to put that 192.168. 192.168.3.1 tab 192.168.3.254. So let's try and ping our gateway first. Make sure that we do have connectivity to the gateway 192.168.3.254, and we do. Awesome. So now we have a default route. No packet should be dropped. Well, heck, I should be able to ping then the 192 168.1.1. I'm just going to go for the gusto. Let's see how far I get. Oh, it's taking long because of ARP. That's the reason. Let's see what happens. Request timeout. Request timeout. Why is that happening? Not unreachable, mind you. It says request timed out. Well, this is going on. Remember? Oh, okay. I thought as I was closed, I was minimizing. I said, did it say reply? Because it wasn't supposed to. Because what's happening is, okay, the packet goes to the router, or the frame goes to the router, then the router is matching up whatever destination it wants to go to, right? So it sends it to this router. This router has no entry. It's not going beyond this point. Heck, it's not going beyond this point right here. Because it doesn't know about the 1.0 network. This router doesn't know about the 1.0 network, and this router definitely doesn't know about the 3.0 network. So if I was pinging the two, somewhere in the two, it may work. Let's see. Let's see what happens using that default route. And we want to ping the 2.1 and see what happens. Still not getting where we need to go. Okay? Because we need to tell this router, all right, you're getting there. It's not unreachable. It's a timeout because you're getting to where your destination is. It just, when it goes back to the router, it doesn't know where to send you because the router has no entry. That middle router has no entry for the 3.0 or the 1.0. So it's not going to be able to send it back where it belongs. That's why you're getting those timeouts. That's why when we're looking and we're troubleshooting and we're pinging and we trace route, we do all these things, we need to understand what those messages are telling us. Unreachable, we never made it out our own gateway. Or we didn't get to a certain point, okay, out of our own network. But when you say request timeout, that means it did get there. It's just that device, that remote device, or one of the remote devices, did not have an entry to send it back to me. That's what that means. So what do we need to do? We need to go ahead and configure static routes in the middle router in order for this network to work. All right, so let's go ahead and do that. Very simple. Same type of syntax, okay? Same type of syntax, but this time we're actually going to give it the networks that we don't know about, which is the 1.0 and the 3.0. So we have default routes on either end, but we don't have it on the middle router. What is it, Cisco? All right, config T. So we're going to go IP route. Destination network 192.168. It doesn't matter which one you do first. It has a mask of out my exit interface. This is 2. This is going this way. That's where the 1.0 is. So it's going out my S001. So my exit interface is S0/0/1. And now the other, and I'm going to up arrow. I'm going to cheat big time. It's going to be going this way, so it's 000. And then I'm going to put at the 3.0. So now I have 2 static entries to either network. Now I know about those networks. So once they get to me, I know how to send it back. So let's copy this. I'm going to cheat again. Wow, really cheated. Do W. That's the only command. Really, you need to do exit, and then you do a copy run start. All right, let's take a look at the routing table. I did a Control Z at that moment. I'm going to do a show IP route. So now, in your middle router, and let's bring this up again, we have 2 static entries. We have 3 connected routes, right? The 3 connected networks that we know about, the 4, the 8, and the 2. But we now told it that, hey, there's a 1.0 network that's going to be, you got to send it out this interface. and there's a 3.0 network that you got to send it out that interface. So now let's see what happens. All right, which IP address? Let's ping the 2.1. We got a request time out last time. Let's see what happens. Now we get a reply. Why do we get a reply? Because it got there, and when it went back up to the router, it said, okay, I know where that's at. It's this way, and sends it to the other router. Let's do a 1.1. It's Ethernet. That's why the first request timeout is going to happen. All right, but you see, you got a reply. Do it again. Now the ARP cache is filled. We know how to get there. Boom. We get 4 replies. So here you have, on the edge routers, you have 2 static entries. You have 2 default routes. And in the middle, you have a static entries. 1 for either network. So you're using a combination of routing, if you would. All right. With static routes and default routes at the end. All right, next lesson, we're going to go to the live routers, and we're going to repeat what we just did, but we're going to do it slightly different, where we're going to go ahead and change the administrative distance. I'll see you there.